broadcast for up to 8 hours. That's exciting. All right, guys. So, like I mentioned, we might have sort of a bit of a skeleton crew. I know, for example, Giovanni's on holiday, Matteo's on holiday. I know Cord was just at this meeting that I was just speaking at and maybe unavailable. I know Johannes is also at this meeting, is possibly unavailable. So it takes out a bunch of people. Maybe Andre and Sergey will still show up. I didn't hear any reason why they wouldn't. But maybe we'll just make it a short one and focus on it. I debated, knowing this, I debated canceling it due to lack of attendance. I still wanted to make sure that we did this every couple weeks, and didn't want to push it back, which I already did very recently. So thanks, guys, for joining. We'll just we'll just go through some topics here that are interesting to us, and then
yeah, that's no problem. It probably makes sense to have a as you say, like a very regular meeting time, which might in the long term help people to stay consistent. So
yeah, exactly. I didn't want to check up too much, so I already did that once. So yeah, good. All right, so my update then. Let me just share here. Part of the agenda. So in terms of journal clubs, so we had this SciUnit journal club this past Friday. I will include the link here. I believe it's already up on the YouTube channel. Actually, let's go ahead and check it out. Go ahead and bring the live link in. This is a very nice one with Rick. Yeah, there it is. With Rick Gherkin, who also I was speaking with earlier. Today he's also here. So I'm in Leiden for the neuroinformatics meeting, for those who don't know. And so we presented on OpenWorm up here. So here's a link to that. Very nice presentation on how to bring the idea of unit tests from software engineering into science. And there's a thread on the mailing list directly related to that guy. And we actually will have another journal club. It's not yet been advertised. We're working that up as we speak, but this DevoWorm so-called project will be presenting, I believe, on the 15th of September or thereabouts. So watch out for that, and I think that'll be a nice opportunity to hear from this other perspective on things, sort of looking at the developmental side. We've been carrying on conversations with folks interested in computationally representing the development now for more than 6 months, and there's really a fairly energized group, and I want to kind of incorporate them and integrate them into everything else that's going on. So I think that will be a really nice chance to do that. I'll make a call out for panelists on the list, as we still have a little bit of time until that one happens. But look out for that one. That should be quite good. And then so we just presented at INCF in a panel that was on the topic of open collaboration in computational neuroscience. And so I presented this talk focused on C. elegans, obviously, in the project that we're doing. And I posted the slides. We tweeted about it. But I think this was kind of nice. I tried to feature as much as I could. I was only given 17 minutes to present, so I could talk about absolutely everybody's work, unfortunately. But I tried to get in as many of the highlights as I possibly could in there. And the full presentation will be up online. They're pretty good about that. At INCF, they've posted these talks before. So when that's ready, we will also share it from the YouTube page. But a lot of folks, in this community, getting pretty excited about this stuff, and lots of interesting crossovers with other projects as well. So that's moving forward. And yeah, those are the two major updates that I have for the moment. And so let's go ahead to folks who are here and see what's new with them. So Michael, you are first on the list. Oh, and Balash.
Okay, so I can...
Hi, Balash. Good. We'll have a talk on that stuff too. Great. Go ahead, Michael.
Yeah, so I can give an update for the movement validation team. So Jim and I met late last week, and we caught up on a bunch of things, and we discussed the progress on the translation and everything else, and we're still working away on that. As you know, the features are done. I'm working on stats, and Jim's working on several pieces, kind of all over the place. And again, we're hoping to be able to do a full port of the Schaefer Lab code at some point. We're getting there, but it's still some more work to be able to get that done. So I've added some links here in the update document. So I still have that code progress chart that kind of shows the overall effort and links to that. And also I'll keep a list here of the 4 people that we now have on the team: Jim, myself, and then our new recruits, Aaron and Miguel. And Aaron has told us that he's going to have to step away for a bit, for about 3 months or so. But he's done some pretty good work so far in seeing how the machine vision algorithms work and comparing them and running them and sort of getting to the point where he reaches an error or some problem that is non-trivial to overcome, and sort of posting that as an issue on the repository. So that's really really useful as a jumping off point for either himself later on or perhaps someone else. And so that's I think that's great what Aaron was doing there. So good for him. And in the last week, personally, I also worked a lot on the documentation for the repository, getting it to be more friendly for newcomers. So I made a guide for contributors and really simplified the README page. I tried to take, to be honest, PyOpenWorm and NumPy were my 2 examples for this. Try to really simplify it, because I think accessibility is key when it comes to getting more people involved. That's just my instinct. I don't have any proof on that, but that's my instinct, that the easier it is to sort of understand initially, the less of a barrier it is to people to contribute.
I agree. I think that's a good instinct, and that's been my experience as well. So, yep.
Great. That's my update.
So,
all right, good stuff.
Michael, what is the format going to be of the output, the validation output, if I could ask?
Yeah, that's a very good question. That's certainly not fully defined. We have the statistical output that involves basically showing a series of histograms showing the distribution of various statistical features, and then I guess the way that the Schaefer Lab had done it, or the way that Ev's thesis basically had it, Dr. Ev Yamini, he had like one worm compared with one other worm, and he would show statistical bounds comparing one feature at a time. But for us, I think the idea was to aggregate that one step further into a fitness function, so that we had like a one number between 0 and 1, or between 0 and 100% or something, to give us the final score as to whether it's similar or not. So we haven't done any work, as far as I know. Jim can maybe speak to this, but I don't think either of us have done any work thinking about exactly what the calculation would be for that, whether it would be like an equal weighted average of the statistical features, or whether it be some other weighted average or something. And it's certainly open to your thoughts on that side of things. But I think that would be the idea. It would be a number between 0 and 1 would be the final output.
A good approach.
Sure, I'm going to be a similar conversation with Greg Stevens about this validation stuff, and I think it's good to aggregate all the features into one statistics, but just to say that it is value of 0 between 1 and how similar is the behavior, that can be, I think, misleading, and I think that's something that some people I know certainly would jump on. We are here just extracting statistical features, but we sort of like also my approach that is somewhat perpendicular to what you guys are trying to do. You are just extracting these statistical features, but it doesn't cover everything that is to behavior. You're getting some important stuff, like, I wouldn't argue against that, but how do you measure the importance of the frequency of the turns versus the speed of the locomotion? You can't do anything else other than just arbitrarily put a number on them. So I really like the histograms, but I think it's much better than to represent that more complicated information, because the issue is more complicated than just putting it into one single number. So I think, yeah, of course, it would be really great if that would be one index that tells how the simulation is worm-like, but at the same time, I think scientifically speaking, that is just not a realistic goal, or at least not at this point how well we understand C. elegans behavior.
Yeah, that's certainly fair. And however people want to be interpreting this data is fine. I think the idea was only that in order to provide some kind of feedback function for example, a genetic algorithm or something, you'd want to have a one scalar value that could be used to evaluate the fitness. But I'm sure you're right, Balázs, that and obviously you know way more about this than I do, about the exact way of characterizing how closely one worm matches another, and it's obviously multidimensional for sure. So once we get to that point in the code base and we can actually make these interesting decisions about how the final output will be rendered, I think we'll be in a very interesting place for sure. I'm just hoping to even get to that point where we can try to answer those interesting questions of whether how the output would actually end up.
Yeah, I think just sort of like one issue that sort of like what I would be uncomfortable with, calling it a validity index. I think it's good, as you mentioned, to have a scalar value so we can use it in a genetic algorithm, but I think it is important just in how we treat that scalar value, just to acknowledge that it is something that we've made up and it's not intrinsic to the behavior of the worm. That's all
Sounds
my
good.
point.
Very good point. Okay, thanks.
Yep, agreed. Cool. All right. Let's see. I guess we got Tom next. Yep.
Okay. Well, last week I spent some time incorporating Parik's API to run the C302 simulator tool into Bionet, which I did manage to do. I took his advice to create a configuration file where you can specify the neurons that you're interested in, including the inputs, the stimuli he calls them, which is okay. And so that's what I did, and got that running on Windows. Had some troubles on a very, very small scale, even a tinier scale than the whole pharyngeal setup, because I was running on just my laptop. Had some troubles getting it running with the neural ML package in finding the right. There's another integrate and fire cell component in there which I couldn't find at this point, but I'm sure it's findable because I found it on Windows somehow. So that's a little hiccup there, but not a big deal. So to sum up, C302 is actually incorporated. Haven't done any large-scale testing. Looking forward, I'm sort of inclined to think I might sort of document what I've got so far and write it up. Since I've been working on this for about a year, maybe it's a good point to spit something out. And anyway, that's about where I'm at. Aside from starting school this week and faculty orientation yesterday, so things are going crazy right now. So but I'm sure you're all used to that stuff.
Well, depends, but certainly from the student end. But that's cool. Yeah, so thanks for putting some content up actually on the docs as well about this. So,
oh yeah, I did that too. Yeah, right.
Little one thing that's up on the latest version under the model optimization project, and that's a good piece. But yeah, I think writing it up more, and really, I mean, as much as you can write up in the README itself, I think is helpful too. Whether you put it there or ultimately put it in some sort of a thing you'd submit for publication. Either way.
That's what I'm thinking of, actually.
Yeah. Okay.
If anybody
yeah. Well,
has
maybe,
any ideas or comments on that, I'd be happy to
okay.
listen.
Yeah. Well, I mean,
Yeah.
we're so close to finalizing this perspectives article, and then I'll have another slot free for a new manuscript. But yeah. So.
Well, keep me up to date or on whatever.
Okay. Sounds good. All right. Very good. Balash, how about you?
Yes, so I got two updates to give, and the more important one is the perspective article. So I sent out a short email to the core list that I've emailed the editor and the reviewer himself, who still have some comments to it. They haven't responded to me, but I look at it more as a sort of like it's okay signal. I guess if they would have a problem with it, then they would certainly let us know. So yes, I said I didn't hear back from them, but I think that means that's okay.
Yeah.
So I worked on the document that we created together, Stephen. If you go and check it now, I think it is in a better shape where we left it. I specifically worked on what exactly to write to the reviewer. I used what you started, but edited that. Also, what is a more finer point is what to add exactly to the data representation website. I have made a few notes there, but I don't that's something that I still have to look into. Tomorrow I have the afternoon for that, so tomorrow evening that's going to be certainly extended what we need to add. And I also have one more sort of like slight concern about it, and I don't want to get into the details yet because I first want to read up a little bit on that. But anyway, if tomorrow you're going to check what the documentation that we prepare, I think it would be also useful. What do you think we still need to add? I mean, both stands for Stephen, but for everybody who is interested in pushing this forward. Tomorrow, after I'm finished updating, what I think should be in the document, I'll send out an email just as a reminder to the core team that hey, this is still a hanging issue. And then after that, it's sort of like I'm sort of finished with it. So then it would be useful to have some input from the community. So that's one thing. That's the perspective article. The other thing is this motif validation engine that I'm building up on my own for my PhD. And right now it is working for Drosophila. I'm getting some funny-looking results. Sort of like the motifs don't separate very well. Like they don't form, strictly speaking, clusters. I'm using right now various fuzzy clustering algorithms, but nonetheless, like I'm pretty sure that it is just how Drosophila larvae is. But as a test case, what I also want to do next is to apply it for C. elegans, of course. And not just to apply it to my own, but I would like to push this into the OpenWorm code base, something that's a different approach to the validation. So actually, just before coming up to join this Hangout meeting, I was just typing an email to Jim and Michael to see how we can incorporate my code base into the movement validation, and to get some data from them, and just to figure out how to put into OpenWorm what I have on my computer at the moment. So that's so that's it from me.
Cool.
So Balaz, can you describe briefly? I'm not sure what the Drosophila testing that you're doing.
Yeah, sure. So have you heard of the concept of the eigenworms?
Maybe.
Maybe. Not sure where to start.
Okay, I heard eigen and worm, but yeah, okay.
What kind of an eigenfly? Is that what's going on here?
Yeah, exactly. It's the eigenmaggot. So there is Greg Stevens. Is a guy at the University of Amsterdam. He's an ex-physicist turned to brain science, and he had this very neat paper coming out in 2008. And what he did is that he did his recordings of the worm crawling around, and he just used some simple vision algorithm to extract the midline. And basically, he showed that given what the worm is doing during its unconstrained behavior, so there was no chemical stimuli whatsoever while he made these recordings, that the shapes can be decomposed into 4 fundamental shapes. Or another way of saying that is that there are 4 fundamental C. elegans body shapes, and you can add them up in different proportions, and that's always going to give you, and that is an efficient representation of C. elegans body shapes.
It
And that's
explains
how.
about 9% of the variance of looking at worms moving around.
Yeah, so basically, the point is that what this method is doing, if you are looking at a worm, then you only need 4 numbers to describe its shape very accurately. And if you think of behavior as a sequence of body postures, then what this method allows you is that it transforms behavior into a 4-dimensional time series, because to describe the body shapes, you only need 4 numbers. And of course, what the neat thing is that there's a lot of time series methods to which you can apply it. And I did the exact same. I repeated this method for Drosophila larvae, which is also just sort of a worm bigger than C. elegans, and there are many important differences, but the same principles can be applied.
That's an important point, by the way, and let me just highlight that. When he's talking about Drosophila, don't think about things with wings and legs.
Yes, I mean the maggot.
Worms. It's like little worms.
I was kind of thinking it, yeah.
Yeah. Sorry, I missed that obvious point. Yes. Yeah. So So what I'm doing with this, so I have this 4-dimensional representation of the behavior of the larvae, and I'm looking for motifs in it. Sort of like what are the repeated patterns in the behavior. And sort of like where I think it is, for example, can be useful in terms of, well, for Drosophila, one of the things that we were interested in is that people distinguish turn events and hat cast. Hat cast when just the larvae is sort of like sniffing around, looking for chemical gradients. And some people argue that these are 2 distinct behaviors. It's either a hat cast, either a turn. But some people said that there is a spectrum in between the 2. So sort of like that question motivated it to see if you can computationally really distinguish these 2 events. And so far the answer is that no, it looks like it's really a spectrum, not 2 distinct behaviors. So just to give an example of how we could use it for C. elegans, so for example, what the movement validation guys are doing right now is that let's take one of the features I think is the frequency of omega turns. But what is an omega turn? They have a definition of an omega turn, but we put that definition into the algorithm. It's not that we mine the data and from that we discover what is an omega turn, but it is sort of like a top-down constraint on a top-down definition of what an omega turn is. So what I think where sort of like we can sort of I think my method will be useful is to define these events in a computationally principled way. That's the main idea.
Balash, can I ask you a question?
Sense. Sure.
So maybe I didn't hear this, but were you saying that you're applying Andre Brown's eigenworm paper to Drosophila? Is that what you're saying? Because I'm familiar with that particular paper from the Schaefer Lab work. Is that what you're talking about?
Yes, the idea is something very similar, but so there are 2 papers relevant to the Schaefer one. One is the C. elegans behavioral database, and the other is the genes affecting locomotion, something like that. And yes, they sort of try to do exactly the same thing. They also talk about motifs, but that is actually a paper that we are going to be quite critical of in the paper that I'm writing at the moment, because how they define motifs is just nearest neighbors, which is not really a good definition for what motifs are. Yeah, give me 1 month, and then I hope the publication will be out, and then it's going to be all written down neatly.
So there's sort of 3 papers. There's this earlier one in 2008 from Stevens, and then there's the 2 papers from the Schaefer Lab, and all 3 of them analyze behavior. The Stevens one didn't use the same worm tracker and wasn't based on the data set that we have, but it was implementing a method similar to that.
Well, yeah, but what's important, I think, is that the original paper, they don't talk about the dynamics. They just define the space of shapes, but they don't say any or very little about the dynamics. So I think it, really important and the interesting questions begin.
So just one quick comment about how incorporating your code into our code base. One fundamental flaw with the machine vision algorithm that the Schaefer Lab uses is that it does not identify omega turns in a robust fashion. It sort of detects them only by the fact that it couldn't segment frames for a long enough period of time, and it just assumes that was an omega turn. But they don't actually have a segmentation algorithm that can segment the worm when the worm touches itself, basically. So I don't know if that means that you can't use the skeleton data that we produce then to get the output that you're looking for. We're working on fixing the machine vision algorithm right now, but for now,
this problem is actually so when I was in Barcelona, sort of in July, Greg Stevens was there, and one of his PhD students is working exactly on this problem to do the segmentation when the worm intersects itself. And he showed me his videos, and it's been solved. As far as I know, he's writing it up. So there should be a paper coming out quite soon that solves this problem. So you're going to be able to have the eigenworm components when during omega turns.
Where's the customer go?
Sorry, say Stephen, didn't hear you.
Where's that going to go? Okay, one last time, because I think there's a delay. Where is the code for that going to go?
Oh, so the guy, like, I was having dinner with him. This was like after 5 pints, bear that in mind. But he seemed to be, we had a chat about OpenWorm, and he seemed to be pretty enthusiastic. I did not specifically ask, or at least I cannot remember asking him specifically if you are going to be able to use his code. But it seemed like that he would be very happy to give it to us.
All right, well, 5 drinks in, it sounds like a good time to bring up the topic of code sharing.
Yeah.
And you not necessarily remembering that he agreed doesn't necessarily mean he didn't. So. Yeah,
exactly. It's a bit of a gray area. Yeah. Actually, I didn't know that he was also working on C. elegans. It was a mid-sized conference, and we just in one of the dinners we started to chat randomly, and then we find out there is a great amount of intersection in our work. So. Yeah, but that time it was too late to be sober. So
next time you're 5 drinks in, please sign the MIT open source.
Okay, I always have one in my pocket just in case.
All right, so you're on point for corralling that in once to get connected. Is that the more things that the code base can do, the more users don't have a reason to rewrite it, basically. The more reason they have to just pick up what we've got here and reuse it and then add to it. So that's great. Okay. Very cool. By the way, since we were talking, and Michael, I hope this is not putting too much on your plate, but another volunteer who has OpenCV, which is the library for doing a popular library for doing computer vision, has stepped up and asked it how they can help, and I've chucked an email over at Michael to see if perhaps if Andre, if Aaron is going to be off for 3 months, perhaps there's an easy slot for this gentleman to pick up. His name is Theo. So I spoke with him, I believe, a couple weeks ago, or maybe just last week.
That sounds great. Yeah, that's fantastic.
Well, so we've got a steady stream of folks that are actually interested in the computer vision problem, and so the more aggregating we do on that, the better. And so yeah, same thing with this omega turn thing. Hopefully we'll be able to put stuff together there. Very nice.
Just one thing that we are talking about the vision. So I know that people in the Drosophila community having various people working on trying to resolve collisions. So to be able to do mass assays, does that method exist for C. elegans? People working on it, just out of curiosity. Now that we talked about vision, do you guys know about anything?
I think not an expert enough in the details of the algorithms in this space. I'd say we can put that question to Andre really, and see and the other folks in future obviously.
Okay.
Cool. All right. Well, guys, it looks like we didn't have any latecomers, so I think that's sort of the meeting for this time. I know that there's been a pause in the Geppetto meetings, but there'll be another one of those for folks who are interested in that on the 8th of September, the regular time. Obviously, there's a lot going on online. I'm feverishly working away as well. I didn't update this earlier, but feverishly working away at working with our Google Summer of Code student who's just basically finished his term, but is graciously standing on to finish to incorporate his work into the master branch for PyOpenWorm. So I've been going back and forth with him. So you can see a lot of that stuff still up on GitHub and following the issues on there. And Michael, are we still on for something? I think tomorrow. Me.
Yeah, for sure. See you then.
Okay. Awesome. Great. All right, everybody. Anything else? Anybody has questions? General comments?
Are we close to setting the final time for the meeting? It sounds like the vote is basically complete. Be nice to get that.
Yeah. If you haven't voted on that topic, if you've received the email, not everybody here has received the email, but if you have not voted on that topic, go ahead and set it. I don't want to bias it by reporting the vote early, but yes, this is for the retreat location. But there is a growing winner, but like I said, I don't want to bias it by announcing it yet because it's not official. So if you haven't done that, please do. And if you haven't gotten it, you'll be hearing about that soon. Okay. Great, guys. Thanks very much. We'll do this again every week, same bat time, same bat channel. So we'll be then.
Thanks very much.
All right.
See you guys.
Bye.
Take care.
Bye.